So I decided I had a whole bunch of scraps of this gauge plate that I bought. What did I buy it for? To make the cant twist clamps, right? Remember that? I don't remember what the thickness it was, but I have all these scraps left over from the CNC work cutting out the sides of the cant clamps. So I've got a big piece in the middle here I can use, plus I got some other scraps that work. The gauge plate is not probably the best thing to make this out of, but if these don't bend on me, they should be just fine, actually. I mean, it's a pretty sturdy piece of steel, but it's just mild steel, so it's not as tough as the steel that the tool steel. So anyway, but I think it's going to work just fine. And I went to a little more trouble this time to make the initial piece. Instead of I was going to take it down to the correct thickness, which is a little over 70 thousandths, and the correct width. But I decided that I would do what I did last time and improvise. So it's actually about 27 thousandths too thick. So I decided to go with that and just make it a little bit narrower, but make it so it fits the Anderson scraper perfectly. So I fiddled around a bit. I just took a 3/8 end mill and I took a little section out of the center of it on each side. You can see that probably in the camera. And I had to fiddle with it a little bit, but I got it so it fits perfect in the scraper. No wiggle, no nothing, absolutely perfect. This is much better than the ones that I previously made. So and I can just flip it around and it works in this end too, no problem. So now what I'm going to do, I purchased an extra piece of carbide. Now I don't know what I did with the darn thing. I had it around here someplace. Oh, where did I put it? Well, I've lost it. Don't know what I did with it. Oh, here it is, laying right here on this bench. So there's a little piece of carbide I bought. And so I'm going to braze that onto this piece right here. And it is actually just a little tiny bit thicker than this the piece of base metal here. So what I'm going to do is I could either shim this up a little bit when I braze it on there, or I could just lay it flat on the fire brick and just braze it on right like that. I don't think that's going to make any difference in the sharpening of it. So anyway, that's the plan. I also want to say that I got a bunch of welding goggles around here, and most of them are too dark for doing brazing work. So I don't know, for about $7 on Amazon, free shipping, I purchased some glasses that go over these glasses that are the lightest shade they have. I think it's a shade 3. An IR shade 3, I think. That must be infrared shade 3. I don't know. But anyway, so I think I have one pair of goggles that changes automatically, and I think that might go down to a shade 4 or 5. I don't know. But they're kind of a hassle, and they don't work real well. So tomorrow. Probably tomorrow. So the next day, maybe Wednesday, I'll finish up this video and I'll braze that on. And I will say that I don't know what I did with it now either. I had some, oh, here it is. This flux that I was talking about, it does actually work really well. If you get it too hot, it will burn off, but it takes a lot to burn it off. Actually, if you watch your brazing and you're really careful, you won't get this too hot. I think this I forget what the temperature range is, but the high temperature range is 1800 degrees Fahrenheit. Let's see. So it doesn't say, so whatever that is anyway, I guess that's about 982 degrees centigrade. I don't know. But anyway, 1800 degrees Fahrenheit, that's plenty hot. This won't burn off. And it's kind of pasty, so you know, of course, once you put the torch on it, but initially it kind of sticks the two pieces together, so it holds them there for. And if you don't touch it, you'll be good to go. And I looked around for some really fine rod because I just used the other day what I had in the shop, but the rod that I've got in the shop is only 3/32 of an inch in diameter, and that's about all you can find. I probably bought the smallest rod at the time that they had at the welding place, the welding store, so it works actually pretty good. It is a little big for this little small work, but of course if I was silver soldering, I have silver solder that's probably the ideal size, but I thought about maybe trying to silver solder this. I don't know. Maybe it'd be a good experiment to try. I guess if it doesn't work, I can take it apart and do it again. But I think what I'll do is I'll braise it, because the last one, it didn't turn out real good as far as aesthetically, but it worked real good as far as strength wise. And I did try out the second one I did, and that one also was very strong. Even though it sticks out a long ways and there's a lot of leverage against the weld, it was no problem. I used it, I tested it on a piece of cast iron and it worked just fine. So anyway, I just wanted to let you know what I'm doing out here in the shop, keeping in touch. Hopefully it's going to be pretty short, because all I'm going to do is braise the carbide tip onto the blade for the Anderson scraper. Now this time I've made a new blade out of a piece of just mild steel instead of tool steel. So it should work pretty good. This blade fits in the shaper really well, and so I guess you could say hopefully practice makes perfect. I'm going to braise this on here a little differently this time. So this is an experiment. Hopefully it works out. I've been using some Harris products for flux that I use for silver soldering. The last time I used a high temperature product, actually it worked pretty good. Somebody mentioned that it could burn off. It does. Once it gets too hot, it does start to burn off. But I think its max temperature is like 1800 degrees Fahrenheit. So it's getting close there. If the melting point of the bronze is, I don't know, 1600 or something, then you're getting close to its maximum temperature. Anyway, this time I'm going to use some different flux. I've been using this flux for like 50 years. It's been on the shelf, and hopefully it's still good. The lid doesn't fit anymore, so it doesn't stay sealed. But anyway, this flux, you just heat the rod and dip it in the powdered product here. It was manufactured by a company called Airco, and it's called Marvell Flux. So I'm going to try that. I've used that for years, so it's always been successful braising flux for braising steel together. That's what I've used it for in the past. So that's the biggest thing. So anyway, what I'm going to do is braise in on, zoom the camera in on the work here, and we'll light up the torch and see if we can get this braised together here. So let me set the camera up a little bit better, and we'll get going. Okay, that should be a little bit better. You know, maybe I could even zoom in a little bit more. Yeah, I don't know how this is going to work. The brazing process doesn't show up very well in the camera, so I don't have any special lens for the camera in order to do this, so I just have to use what I've got. So we're going to go at it here, and this only should take a couple minutes, right? Shouldn't take too long. I've got some. I might mention that I've got a little, I don't know what's going to happen, but I've got a little weight on the piece of steel, and I've got a little piece of music wire set up as like a spring against the carbide, because I've had trouble with these things moving in the past, so I don't want it to move, and so I want it to stay stable here. So I don't know what's going to happen to the little piece of music wire, whether it is going to stay intact or not. So we're going to give it a try here. And I'm using a 3/0 tip on a small Victor torch. And I think I set the PSI for the acetylene and oxygen about 5 pounds, I think. So hopefully it's a pretty soft flame. And so we're just going to get this hot here, and you know, there the flux went liquid on me there. So see if we can. The brass is starting to flow. That should be it. Now I'm probably going to have a little brass to clean off there, that's for sure. So probably a good sized puddle on the top. I tried to be pretty conservative with it, but we'll see what happens. All right, let me zoom out a little bit here. Move the camera up. Okay. I don't know if I'm in the picture or not. I might not be all the way in the picture here. Let me, by the way, Walter, I picked up these light shade welding brazing goggles here, glasses. They fit right over my glasses. They work really well. Very inexpensive, from Amazon. I forget the name of the company. It's called Pyramics. Anyway, they work really well. First time I've tried them. But it's better than fooling around with those goggles that I've been fooling around with in the past. Let's see if this thing's hot. No, this nut's okay. We can remove that. And let's see if we can, if this is, I got some hot water down here. I'm going to just put this in and see if I can, hopefully it'll, if there's any flux hanging around, it'll help with that maybe. Well, that looks like a pretty good job. Even not perfectly centered, but it's pretty good. So, see, there's flux on there, so that's always a pain in the ass to get off. But, so there it is. So I got that brazed on there. So now what I'll do, and I'll include it in this video, I guess. What I'll do is knock off some of this flux, and I'll just do that with the angle grinder, and we'll see how it turns out. The braze job looks pretty good actually, and let's see. It's of course it's flush on the bottom, no problem, where it was laying on the fire break. And it's just barely above the top. So it's actually the thickness of the two metals is not bad. Not perfect, but I think it's going to work out just fine. So this fits into the Anderson scraper really well. I mean, a lot better. No move, no wiggle, no nothing, you know. So I like that. If this mild steel doesn't bend on me, which I actually don't think it will. I think it'll be pretty good. This whole thing is about let's see. I think the normal Anderson blade is about 70 thousandths thick. So this is about 110 thousandths thick. So about 30 thousandths difference, or 40 thousandths difference or something, I don't know. Anyway, that's, so I've improvised with this piece of metal. I took a little bit out on the, in the middle on both sides, so it would conform with the end of the scraper handle. So anyway, let me shut the camera off for a second, get set up, and then we'll clean this flux off here. Okay, I've clamped the piece of metal to just another piece of gauge plate down here. So I'm going to just clean this flux off here. Okay, that's about the best I can do. Still, flux is damn hard to get off. No, that's the best I can do on that. Of course, I can't get it out of that groove right there, but I think I'll have to chip some out of there, I guess, eventually. Let's just clean up what I can on the other side and call that good for right now. No flex on this side, probably just got some brazing clean off. pretty hot. Okay, so with that, you know, I'll stop the camera here and see what we can. I'll have to clean that up a little bit more somehow. So that got a little bit of it off with the angle grinder there, so doesn't clean it up completely. These things are always a little difficult to clean up. I don't know what the answer is. I have some acid, probably clean them up a little bit, but okay, that's where it's at right now. So I'm going to do a little bit more work to clean it up, get the blade radiused and sharpened, and we'll be back in a few minutes. Okay, I really couldn't clean it up too much, but I did. See if I can. I don't know if this thing zoom out a little bit more. I got to get a little bit further away here. So I did grind the radius on it. I don't know if you can see that. So I ground it to a 4. I think that's a 4-inch radius or an 8-inch diameter. I think that's what that is, but I don't remember now. And I did grind the end on both sides, quite sharp. So I'm going to give it a test now, but I banged it good against a steel object. It doesn't move, so I don't think it's going to ever come off there. One thing about this flux, the flux is really hard to get off. If I keep grinding on it, I'll just grind the metal away. The flux is harder than the rock, so it's hard to get that off. But that's all right. It doesn't make any difference. It doesn't look beautiful, but I think it's quite solid. And that flux works really well. There's no doubt about that. So I don't know if that's an anti-borax product or what that is, but I've used that for like 50 years. That's what they had for sale years ago, where I bought my welding supplies. So that's what I've always used, and that can has lasted all these years. It goes a long ways. So there's that. So I'll call off now and post this